Bismillahirrahmanirrahim. Assalamu alaikum. My name is Ahmed Malik, and I am from FAST Alumni Association of North America. Welcome to our 14th seminar, An Introduction to Cognitive Computing. And for those of you who have joined for the first time and want to know what FAANA is FAST Alumni Association. It's North American chapter, so we have 5 campuses in Pakistan. So we've been working to generate funds for the students in need in Pakistan, so all the 5 campuses. So we've been doing that for the last 10 years. And recently we have started to support the innovation and research activities at all of these campuses. It's just started last year, but we hope to grow it just like we have grown our scholarship funds. So one other thing we have done is we've been doing webinars for a number of months now. And today our speaker is Ahmed Sattar. He is a FAST Islamabad graduate. He joined FAST Islamabad in 2000. And he has worked at Teradata, and recently he's with IBM. And he lives in Atlanta, Georgia, has been involved in communication, media, and finance industries. And we're very happy to have him here to give us an introduction for the cognitive computing. And this is not just for the students, this is also for students like me. I've been working here for a long time, but I've not come across using cognitive computing. So we thought this would be a good idea for an alumni to share this with all of us. So with that, I'd like to give it over to Ahmed Sattar. And Ahmed, would you like to start with a little bit of your introduction, and then we could jump into the presentation. Just one thing that we can ask questions in the middle, but I would also appreciate if you guys can chat. I'll be looking at the questions and try to interject those questions. So we will also open the questions and answers towards the end of this seminar too. So thank you. Ahmed, over to you.
All right, thank you, Ahmed. So like mentioned by Ahmed Malik, I am a FAST alumni. I graduated in 2005. Since then, I've been working in the IT industry. I joined Teradata actually back in Pakistan, and then I moved to the US. I did my MBA here, and then since then I've actually switched jobs and went to IBM. So let's share my presentation. Can you guys see it?
Yes.
Okay. So like Ahmed mentioned, it's the topic is Introduction to Cognitive Computing, and then a small application of data engineering and data science on an industry, the education industry. I've been working on this project for a couple of years. So why I chose, so this is the agenda: Introduction to Cognitive Computing, what is data scientist, what are the different patterns that they use, and then finally the application of data science. So the reason I chose this topic is that because there's been a lot of talk about AI nowadays, and it's actually a little scary because it is saying that it can take over all of our jobs, which is true in a sense, but this also brings us a lot of opportunities. So the jobs would be changing, especially in the field of IT. And that's where there's an opportunity to learn about this topic. And then data science is a very important thing that feeds to cognitive computing and artificial intelligence. And then I will talk about how we apply data science and data engineering. These two kind of work hand in hand. So that is why I put them both together. So let's start with the topic. What is cognitive computing? So Basically, it refers to a system that is able to interact with humans in a natural manner. So what that means is that it can use vision, hearing, and it actually responds to you in a way a human would. The difference over here from AI, and there's been a detailed webinar on AI before, should be on the YouTube channel. So the difference here between AI and cognitive computing is that cognitive computing is meant to make us make more smarter decisions. So it helps us, whereas AI is thought that it can actually make the decision for you. So let me give you a scenario. There's a huge database of medical records, and we want to find a suitable treatment for a patient. So if it's an AI assistant, he will find the most relative option, and it will suggest that to the doctor. Whereas in cognitive computing, it will give out the final thing, but it will not suggest anything. Maybe it will give a recommendation, but it will not go to the final C, and it will give you drawbacks and pros and cons. So it's more like how you would say, maybe like a Google search, or I would say like how you use your navigation. So it's very good when you're going to a new place, and it takes you there, and then at the end, you use your own senses, like, why can't I take this left, and why do I have to go this long route? Maybe the map doesn't know everything. So that's where it differs a little bit. And there's a small picture here which describes how cognitive computing relates to artificial intelligence and machine learning. So it actually encompasses all of that, which means that all these things are required for cognitive computing to work properly. And then a small talk here about machine learning. The machine learning actually requires a lot of data, and this data is usually delivered through data science. And this machine learning basically makes the machines more smarter. So as the data gets better, the machine will know more, just like how you train small children. Like as they start to learn more things, they get more smart. So, so this is so the tool that IBM chose for cognitive computing was called Watson. Don't know if you've heard of it, but one of the biggest wins that Watson achieved was in 2011 when it won a game show called Jeopardy. So this game show was basically a general knowledge quiz competition. So you give answers, and then the contestants have to see what that answer was supposed to be for. So for example, like if you have an answer there which says, "This father of our country didn't really chop down a cherry tree." The correct answer is, who is George Washington? So that's how you would respond. And as you can see, this requires you to think, to interact, and basically use your senses of hearing, vision, etc. And that's where it became very famous, and it thought that it could solve a lot of problems. So then we go to how it was fared after it did that. So Watson became very popular in the healthcare industry because there's a lot of data in the healthcare industry, especially like for cancer. There is a lot of data which needs to be sorted through. So physicians need to be trained on all that data. And that's where artificial intelligence or cognitive computing becomes really helpful. So what we saw was that Watson for oncology actually was giving really great information when it comes to lab results. So it was able to train itself on 13 different types, and the accuracy was very high. This is because it was mostly working on supervised learning. So a little bit about how the AI or cognitive works is there are two types of learning. There's supervised learning and there's unsupervised learning. So supervised learning is where you already know the patterns in the data, and you are basically training your AI to say that this is what we're expecting. This is what we did in the past. So now, since you've been trained on this, now try doing it on this data. And because of the large amount of data, the machine can do it pretty fast. So there was great accuracy. But then where we started seeing drawbacks was that a lot of the information about the cancers is in the doctor's notes. So sometimes they can have summary. So for example, you can write Islamabad as ISP, IST. So if Watson is not able to interpret that appropriately, it gets lost. And sometimes there is things in context that you meant something else. You could be talking ironically or things like that. And all those things are where Watson started to have some problems. And then once it started to expand its horizon, it was not really able to deliver the results that were expected. However, there's still work going on, and it might improve. One other drawback was that it was being trained. So since it's supervised learning, it was being trained on a certain doctor. So if a doctor himself is biased towards a certain treatment, Watson will always suggest that, and it also becomes biased towards that. So that were some of the problems that came forward and that are being worked on currently. So now we move on to our next topic, which is data science. So what is data science? So data science is a multi-discipline area, and it changes the way organizations solve problems. It is a mix of AI and math, and you can use it to the machine to apply your different statistical algorithms. So it requires some knowledge from the person himself, but a lot of it is done by the machines. And basically, because machines are able to process so much amount of data, they are very useful. However, as a person, people are able to identify patterns a lot better. So this is kind of bridging that gap. And also it requires a business acumen. So this is important. So data science people need to know a little bit about the domain of what they're working in. And that's where data science is bridging that gap. The most important thing I feel as a data scientist you can do is that you can create a data-driven culture. So we'll go into more detail about this, but what it means is that you can tell your managers or your clients to start making decisions based on what the data is saying, rather than their own biases or their own gut feelings. And that's where the data scientist can really help. So this one is more of a motivational slide for people who are looking to get into this field. As you can see that the salary ranges are pretty high, and there's a variety of things you can do as a data scientist. So you can be involved in statistical analysis, or you could be doing sentiment analysis of Twitter data. So, and the one good thing about this is that as you get more knowledgeable, especially working in a certain field, this becomes more of an art. So you can transition from just using data to actually driving it more to the way you think you know the business. And I'll talk about more in the next slides what that means. So Christian, this is one of the models that is suggested as a cross-industry platform for doing data mining and data science. Over here, this is an iterative process, so you keep on improving upon your results as you move along this cycle. So the first step is understanding what the business is. So that's where you start to learn, like talk to your clients, or if you are working in a company, to your managers, and understand what they do on a day-to-day basis. Once you have a good feeling of that, the next step is understanding the data. So this is where it's different from business understanding, is that sometimes people are not aware of what their data is telling them. So the data actually helps you explain that are those assumptions that you know about your business, are they really true, or maybe they were never implemented, or you need to rethink what your business is doing because your data is saying something different. So once you understand the data, then the next step is data preparation, that falls more into the realm of data engineering. And then modeling, we'll talk about some of the different various models that are available. And this is where you choose based on your data and the initial steps you took, which models are better. And then finally, evaluation is kind of your testing step for doing the data science. And once your accuracy is where it should be, you go ahead and do your deployments. So this is a slide where people usually use to pick a solution. So what our problem was more related to the top part, because it falls more into predictive modeling. But you have to remember that all the previous steps of Christian, they are very important when you're picking your model, because your assumptions and everything about the data is very important when choosing the right model. Also, it is also important because sometimes your model can look great, but if you have not prepared it properly or looked at all the assumptions of the model correctly, the results might still be misleading. So that's why it's important to keep the steps in mind when choosing your model. Okay, so now moving forward to the problem that we had in hand that we were trying to solve. So this is a government-run institution, so all the teachers are given the same salary. So there is no way for the teachers to basically get motivated or try to go the extra step to help the student. I mean, obviously, inherently, as a teacher, you do want your students to do good, but this was more of like giving them some extra motivation. So the salaries, since they were fixed by the state, the way to motivate them was through a bonus system, and we needed to differentiate the different teachers based on some criteria. So there are 4 criteria here listed here: school assessment, training, teacher assessment. These are like trainings that they have to do. School assessment is what school they were working in, what are the different assessments for that. There's some trainings that they have to do. So these 3 things were pretty much standardized for them. They had the data for it. The 4th one, student growth model, is where they did not have, they had the data, but it was not in a form where they could use it to apply to the problem. So that's where they needed our help. So when we started analyzing this problem, we came across four critical elements. So all of you should be familiar with what a class is. So there are several sections that form a class, and then the class rolls up to a course, and then that course rolls up to a subject area. So that's where some of these intricacies were in the data. Student, basically the person who is the subject of this, he is being the one who's taught, and the main X variable that we're looking for. And the teacher is the one who will eventually be judged. And then tests are how did they do. So over here, these were some standardized tests. So each school, it was a school system. So each school can have their own tests, but this was a standardized system across the whole school system where they could measure everybody on the same yardstick. So that's where this test was important. So here is a list of problems that we came across. So what we wanted to do was that if they, in order for them to be eligible for the growth, the students and teachers need to have spent 65% of their time together in the class. And the problem would be simple if we actually know like what time the teacher started, when did he end, what time the student started, and what did he end. But that was not the case when we looked into the data. We had to go based on enrollments and assignment dates. So what would happen is that they would just show that the student enrolled at this time, and even if he left in the middle, there was no way for knowing. So you had to go to the next enrollment and see, was that in the middle of the semester? Did he leave? How much time did he leave with? And then another problem was, which is highlighted here in the bottom, is that the teacher sometimes took leaves, and the assignments never changed. So you had to basically go to a different system where you would see their leaves, and then those leaves had to be encountered in the system and said that, okay, this was actually the time that the teacher really taught, and the middle time was for something else. So there's a small model that the team came up with. There were about 16 tables that were used. So these tables were then would be used by the data scientists to perform their analysis. The code was done in a modular manner. So because the requirements kept changing, like I said, when you understand the data, you kind of want some different measures. So it had to be done in a way that you could reprocess everything very quickly, because when one assumption changes, you have to basically rebuild the whole thing. And we tried to make it such that one part of it can be done without affecting the other parts. So eventually, these were some of the project hills that helped achieve this, the model. A standardized calendar. So schools can actually follow different calendars of their own. But since this was being done for the school district, we had to find a way on where all the schools were following a district calendar. And that required some back and forth with the schools, communications, and telling them what the best way was. Then the overlap complexity. So like I said, that from sections, you have to roll up to the class, to the course, and to the subject area. So we tried to keep the durations at the lowest level and test them. And then after that, you're just aggregating them, so there's less chance of error. Incorrect teacher assignments. So I talked about this earlier. we had two different sources, one that kept the assignments of the teacher and the other one that kept the leads. So being able to bind them together was one of the biggest achievements. And then multiple enrollments. So what happens is that in some cases, the students leave the section, but they keep on, they're still enrolled in the other section. Sometimes this was for business reasons, sometimes it was just an error. So being able to find out which ones were really relevant and which ones were not was one of a bigger achievements. And in this, just trying to show a couple of tables that were finally used and were the most important ones that were used by the data scientists. The top one gives you the information of the students, what their score was in the pre-tests and post-tests, and I'll talk about that in the last slide, that they actually had a test taken at the beginning of the semester and then at the end, and then their percentage was calculated based on the difference. And then the other table basically gave you if the student was, the teacher actually overlapped for the amount of time that was required for them to become eligible. Okay, and then now moving on to the data science part. So we had to basically cut the scores into four quartiles. So in order for us to make it more usable for the data science, first you have to determine the clusters. So this is how the clusters were determined: 0 to 25, 25 to 50, 20, and so on. And if you note here, the teacher will get the maximum benefit for people who change from the first to the fourth, because this is where they were before and this is where they were in the fourth one, in the post, and that is giving them the maximum benefit. So now going on to what the formula was. So the formula basically is pretty simple. It's simple once the data is in a form that you can actually use it. But basically the number of scores that count positively for the teacher, and then how many scores or students were actually associated with the teacher. Again, we can see here that the teachers are kind of judged on other criteria as well that I talked about earlier, and this is giving them a certain weightage. So the trainings they did and the schools that they were teaching at and what their own surveys or teacher assessments were showing also had a role to play in the whole thing. So now going on to some of the lessons that we learned here. The biggest problem that we saw was data quality, and that's where all the 5 steps of Christian become very important. So if you have a student who is concurrently enrolled into multiple sections, he would be counted twice, and that would give an inaccurate picture for that teacher. And then if teachers are still assigned to sections and being counted while they are on leave, they might be taking away from another teacher who was taking over for them, or maybe doing double duty to cover up for those teachers. And then there was also scenarios where students were taking tests out of their grade. So it was mostly like a 4th grader is taking a 5th grade test. So you cannot judge them on something that they've not even learned or they've not been taught. So if you started to look in those those tests, you had to make sure that they were not counted. Otherwise, they would give an inaccurate picture to the teacher. And all of this was because of bad data quality. Otherwise, we shouldn't have fourth graders taking fifth grade tests. So in order for us to, when we showed these problems in the data, it actually helped us achieve something. And this is where it ties back to what you can do as a data scientist, is that you can cultivate a data-driven culture. So there was more improved scheduling. When people left, they were giving end dates. The assessment process ensured that students were being given tests for the grade that they are in. And if the teachers left, they were also given exit dates. And if they moved on to a different teacher, even then they were given dates. So that's the end of what I had to talk about. If there are any questions, I would like to answer them.
So Ahmed,
and these are also my contact.
Cognitive computing there. Did you have to use any cognitive component in this use case that you were talking about?
We did use a little bit of Watson, but mostly it was done as a data science project. So we were just building data that we can, once we have enough data, the plan is to use it with cognitive. At this moment, there was not a lot of cognitive piece in this.
Okay, so were there like any other text data or unstructured data in your evaluation, or was it mostly structured data?
Yeah, that is a good question. Yes, so we did have, like I was talking about the surveys. So a lot of that was unstructured data. So we had to go in and train our softwares to learn, like, when the student is saying something, what do they mean about the teacher and their comments and all those things. There were a lot of unstructured data in there. And also what we started noticing was that once this model was deployed, like, as you can see, there is a motivation for the teachers to have a lower pre-test scores. So once it was deployed, we saw that the pre-test scores just started falling a lot. So there are some patterns there that we are starting to analyze now as this model has been rolled out, and we're trying to improve it with the cognitive computing.
Okay, and what's the subject size? How many teachers and students are we talking about?
So this is about 100,000 or more students, and teachers are more in the range of 30,000, 20 to 30,000.
Let's see. There was a question.
But
yeah, go ahead.
Yeah, just to so the enrollments reach in the range of 4 million. So that's where the computer needs to step in as well, because the students can take a lot of courses, and the assignments are more in the lower range, but the enrollments get pretty big over the years.
Yeah, I had one of a very similar assignment done with like 900 schools, 100,000 students, and about 20,000 teachers. And eventually we came up with something called resilience score for teachers. So that was telling us if their resilience score was high, how those schools would perform. So that was another thing that we learned from our exercise as we did it at my previous company. Going back to Watson and cognitive thing, I mean, there was a question that came out about, can people get access to Watson and try it out for free to understand what value it could add before really utilizing it, or how does that process work?
Yeah, that's a good question. So initially, Watson, after 2011, was kept on the IBM cloud, and they were trying to promote it, promote their own cloud, and then you would get Watson. And you can still do that. So you can sign up for the IBM cloud, and just go to ibm.cloud, and they give you, I think, $200 worth of free computing just for signing up. But now they have rolled it out on all platforms, including Amazon and Microsoft Azure, and I think even Google Cloud. So you can use them on any of the cloud platforms. I don't know if there is an actual Watson for like just on-premises work. That might be paid, and it's only given to clients. But if you're just doing for experimentation, you would have to use one of the clouds, basically because of the amount of data you need to process. So the cloud helps you do that.
Okay, thank you. I encourage all the participants to unmute themselves and ask the questions if they have. I read one of the questions that came up in the chat, but cognitive computing is another of the interesting thing. The other day I saw this tool called DIVO, D-I-W-O, data in, wisdom out. And that was an interesting tool. Like, you could literally ask a question about sales of the company, and it would automatically come up with a idea, like data in a visual format. And then you could say, hey, what if I do this in certain area? What would happen? So this was literally interacting with the data in a human voice format. And it just seems like, you know, the Iron Man movie where we have Travis, where you could ask questions and it could reply back. Is the Watson similar kind of thing?
Correct. It's pretty much similar. You can so the Watson Jeopardy win, it actually was pretty much doing what that computer in Iron Man is doing, is that it listens to you, it translates that into text, and then it reads through its own database, and then it goes back and returns back to you what it wants. And there are a lot of steps. Like when you start building it, you see that there's a lot of steps to do. First, translate your voice into text, and then read the text, manipulate it, and then put it back into voice. But the way it's being able to do it so fast is actually pretty amazing. Okay. And that's where actually supercomputers are really going to help out, because I don't know if you've heard, like IBM has one of the biggest supercomputers right now, and they're using Watson and trying to make it better because of all that processing.
Are there any other products like Watson in the market that are competing?
Yeah, I think there is some products that Amazon has, and Microsoft also came out with it. By itself, like Siri is also a product, but it's dealing more with interacting with humans, whereas Watson is more towards data for clients. So it's more structured towards different subject areas. And actually Watson, they've broken it up into different brands. Like one is for healthcare, the other one would be for finance, and all these different things. They're all labeled Watson, but they're actually some different products out there. But yes, there are other products out there who are also doing a lot of artificial intelligence and cognitive computing.
Do you? How would a student who is about to graduate from from FAST or any other college, if they want to get into the data, what are some of the things you would advise them to learn? How would they get into it?
Yes, so I think the most important skill that I found dealing with data is um, using SQL. Like just get yourself familiar with it. Databases are still the major source of all data. So they, even though like unstructured data is becoming really important, and there are a lot of like NoSQL databases and all those things coming in, but you need to get yourself familiar with working with databases. So once you are familiar with that, then you can go into other sorts of analysis, which are using text analytics or um, and sentiment analysis and things like that. Um, Along with that, there is like a lot of open source things like Python and R. All those are being used for data science. So once you are familiar with SQL, then you can move on to R and Python and things like that, and make yourself more familiar to those tools as well.
So do you have any other case studies have you seen that come across for cognitive or?
Yeah, so we did some in one of our case study, which was interesting, was we had to determine if the government should be spending more time building roads or improve their bike infrastructure. So this is like for bigger cities. I think it was DC or New York, and we had to evaluate that based on how many people are using the bikes, how much traffic is there, if we increase the roads, like what are the budgets and things like that. So all those are applications for data science. In the education industry, like there is a Watson for education, and it's working with Sesame Street, and basically they're trying to analyze like how students or little children learn. So like there are some things where like even though they're playing and you think that they're not paying attention, but they are on the background, they would always be attracted to certain things. So Watson is kind of doing analysis on that. Then another application that is being followed on my client is ABC, like ABC model, which is basically you're predicting if certain students are at the risk of falling off and not graduating in time. So based on their attendance and their behavior records and the courses they're taking, it alerts the teachers to maybe try and do a quick, like go in early and help them before they actually start to fall out or get lower grades. So these are some of the applications that I have seen, but it's being applied in a lot of different industries as well. And it's the future, basically.
Okay. Attendees, you feel free to unmute yourself and ask any questions that you may have. I see several people on here. I think I covered the questions that I received. I think this was valuable for us, just getting introduced to some of us that are new to the data, cognitive computing and data sciences. We have covered that topic, but it's always good to see another case study. Any other final word before we conclude?
No, thank you so much for listening to me and taking our time. And
thank you very much.
I hope that I'm able to motivate somebody to maybe come join this field.
Yeah.
And my contact information is here, so if somebody wants to get in touch or learn more about some of the intricacies that we had, I can talk about it with them.
Well, thank you very much, Ahmed Sattar. And with that, we will conclude this. And Jazakallah khair. Thank you. Assalamu alaikum.